Alright, now let's talk about loci of complex numbers. We have got three general loci, and let's talk about them first, then we are going to talk about non-general loci. Right, so what is the first general loci? We are going to have the modulus of sec equals to k. So what is the modulus of sec? Okay, note that it is distance of sec from the origin. So when I tell you that it is distance of sec from origin, it's equivalent to k. What sort of graph comes into mind? It should be a circle, isn't it? With a center at the origin. Because if you were to draw a graph like that, with a center at origin, you draw a circle in such a way, this is when you can guarantee that distance of sec from the origin is always k. So sec is any point on the circumference of the circle. Okay, so when you see a form like that, it is a circle. So what happened if it is the modulus of sec minus a equals to k? It is simply the distance of sec from a equivalent to k. Say for example, you have got modulus of sec minus 3 plus 4i equals to 1. So how do I tell what is a? You got to first rearrange in such a way that you got to first rewrite in such a way that you have got your sec minus and leave in bracket 3 minus 4i. What is a for this case? A is simply 3 negative 4. So what graph do I draw when I see a modulus equivalent to a number? It is a circle that I got to draw, and this time around I have got center at 3, negative 4 and with a radius of 1. Okay, right? So what about the second form? Okay, what about the second form? The modulus of sec minus a equals to the modulus of sec minus b. So what is the modulus of sec minus a equals to the modulus of sec minus b? We are simply talking about the distance of sec from a to be equivalent to the distance of sec from b, isn't it? So what comes to mind when I tell you that this sec that you're going to draw, the locus of sec that you're going to draw will be equal distance from A and B? It will only be the perpendicular bisector, am I correct? So say this is the example given to you. So sec minus 3, okay, I'll simply have my A to be equivalent to 3, 0. What about for this one? Okay, rewrite it a little bit where you're going to have the modulus of sec minus negative 5 minus 2i, because the moment you open brackets, that is when you will get sec plus 5 plus 2i again. So what would be for this? It would simply be negative 5 and negative 2. Draw these 2 points, A and B. You have got your A to be here. You have got your B to be at negative 5, negative 2. Right? Which is a dot here. Okay, so how would you draw your perpendicular bisector? Please make use of compass, okay? Make use of compass. You should be able to draw something like that, okay, using your compass. Join the 2 dots, that is when you will form a perpendicular bisector. So where would your locus of sec be? What would your locus of sec be? Your locus of sec will simply be a straight line, and sec can be any point on this straight line. Whichever point that you take, you will see that it is equal distance from A and equal distance from B. Alright, so that is my perpendicular bisector. When you see modulus equals to modulus. But what happened if it is the modulus of sec minus A equals to K multiplied by the modulus of sec minus B? Say for example, it is modulus of sec minus 3 equals to negative modulus of sec plus 5 plus 2i. The moment you see something like that, the moment you have got K, which is not 1, it could be negative 1, it could be negative 2, it could be negative 4, it could be 2, it could be 4, it could be any numbers at all to take this K. The moment you see a form like that, that is when you will get a circle, right? So how do I tell what circle is this? Okay, how do I tell the center of this circle, and how do I tell the radius of this circle? You will have to then convert this form into Cartesian form. So how do you then convert into Cartesian form? You need to let your sec to be x plus yi, and you work towards getting a Cartesian form, and that is when you will see this is a circle. Alright, and what about the third form? We have got the argument of sec to be equivalent to k, and note that argument of sec is simply theta, angle from the positive x-axis, right? So how do I draw this one? It is simply the argument of sec from the origin, okay, from the positive x-axis to be equivalent to k. Hence, sec can be any point on this line. And why do I say it is any point on this line is because any point that I put that I got on this side will give me equal angle, and that angle would be K, right? So what happened if it is argument of sec minus A? Okay, this one, I have my half a line to start from the origin because it was sec alone. So what happened if it is argument of sec minus A? It simply means you are going to have a new origin, and probably your origin is over here, okay, because A is over there, hence you are going to have a new set of X and Y. This is your A, you are going to have a floating line like that. Okay, right, so let's look at one example. It is argument of sec minus 2i. So what is A for this case? It is 0, 2. Note this, it is always sec 0 that I wanted. Sec minus that I wanted. It is always sec minus that I wanted, and it is always sec minus that I wanted. Okay, to tell what point, alright? To be taken. Okay, so it is sec minus 2i, hence for this case it is 0, 2. So how then do I draw this locus? 0, 2 is simply there. So this would give my new origin, and that being said, I'm going to have my new X to be here, and Y will remain the same. So this is my new axis. Alright, so how do I draw my power 4 angle? Power 4. So this line would give the locus of argument of sec minus 2i equals to pi over 4. Right? So it doesn't constrain you to only have equal, you see. All these loci that I have discussed with you can also be inequality. So what then should I do if these are inequalities? Easy, you got to do shading accordingly. If it is a circle, if you were to see a less than and equivalent to, if I were to change this, okay, if I were to change this into a less than and equivalent to, where should I be shading? I got to be shading the inside. Okay, if it is a more than, I'll have to be shading the outside. Okay, right, so like this one, okay, let's just say it is a more than and without an equal. So where then should I shade? Okay, since it is just a more than without equal, I'm going to leave my circumference of circle in dotted. What do I do next? I'm going to shade it outside because I wanted radius to be more than 1. Okay, so you got to just shade it accordingly, right? So what then for perpendicular bisector? Note this, if I were to change this into a more than and equivalent to, it simply says distance of sec from A is more than and equivalent to the distance of sec from B. So that being said, I would know that sec is closer to B. Correct or not? So if it is pointing towards B, I'll have to shade it towards B. Make sense to you? Alright. And what then about for argument? Okay. If it is argument of sec minus 2i equals to power 4, it is just half a line that I draw. What happened if I were to change it into a less than and equivalent to? That is when I'll have to shade it on this side. Okay, but note that with negative angle, okay, let's just say I have got this one now, argument of sec to be less than and equivalent to sec minus 2i to be less than and equivalent to negative pi over 4. It looks the same, okay, they look the same, but this time around I'm going to work with the negative pi over 4. Right, so what should I do first? Like what I told you earlier, you're supposed to have a new origin to be found. Hence, it is 0, 2. Draw a horizontal line like that, a vertical line like that. Where would negative pi over 4 be? Negative pi over 4 would be there. Okay, so where do I shade? It is a less than and equivalent to. I should be shading over here. Some of you might be asking, but teacher, how come it is a less than that we wanted? Imagine in such a way, if it is 1 and 5 that I asked you, you will certainly say 1 is smaller. Correct or not? But what happened if it is a negative 1 and a negative 5? Negative 5 is smaller. Hence, negative always give you the opposite. Right? So if I could summarize in such a way, I am going to have, let's just say, a half a line like that to give me theta equals to pi over 4. Let's just say another half a line like that to give me theta equals to negative pi over 4. Where do I shade when it is argument of sec less than pi over 4? I got to shade it here. Less than or an equivalent to, same, alright? But one with dotted half a line, another with solid half a line. What happened if it is a more than or more than an equivalent to pi over 4? I should be shading on this side. more than or more than and equivalent to. What about for this one? Like I told you, it is always the opposite. This should give the more than or the more than and equivalent to for negative, and this side of it should be the less than and the less than and equivalent to. Alright? Yeah? So some of you might ask, what happened if it is argument of Isaac? Okay, we are going to discuss that later.